Welcome to Horner's Tech Corner, technology innovations with applicability in healthcare. My name is Perry Horner. I hold a Bachelor of Science in Broadcasting and a minor in Computer Science. I also have a Master's in Business Administration with an emphasis in Technology Management. For decades, I have worked in the IT industry and am continuously amazed with the innovations and ingenuity of new technologies. Welcome to another episode of Technology Innovations with their applicability in healthcare. Today I have a guest who will be talking about securing those Internet of Things devices, specifically medical devices. And this is Drew Ganther. Welcome, Drew, to our program.
Thanks a lot, Perry. Appreciate you having me.
Can you tell me a little bit about yourself, what your background is?
Sure. Yeah. So I've spent the last 10 years in IT training, sales, project management, focusing a lot on the application layer, but done 5 or 7 years in advanced data centers and security. In the past 4 years or so, focusing specifically on security and even more specifically in healthcare.
Very good. So tell us, so we can kind of understand, we know kind of vaguely what Internet of Things are and medical devices are, but what specifically should we be concerned with? What are we talking about here about securing these? What are these devices? How are they connected?
Yeah, this is a great talking point. IoT in general feels a lot like a marketing buzz term that has a similar connotation as cloud before everybody really understood what the heck is cloud and all these different flavors, right? And I think today's version of that is IoT. So what the heck is IoT? How are people defining it? When you think Internet of Things, the connotation of the word or the phrase, everything is Internet of Things nowadays. That's the trend, is everything is starting to become connected to the internet. So how do I differentiate between what I need to consider in an IoT strategy or IoT management or security? How do I define that piece of IoT? In my opinion, what we're really looking at with IoT is those unmanaged devices, meaning unmanaged through traditional asset management vehicles. So these things don't have the ability to load a certificate on them, or they're not, you don't track them in Active Directory. You just don't have them in your traditional asset management approaches, or you can't utilize traditional asset management approaches to manage and track these devices. So that's how I would classify IoT. And then even beyond that, I think it's really important that people classify different types of IoT and the criticality of these different device groups to the business or in healthcare to a clinical process, and really understand the different types of IoT devices that are connected to the network, their interconnectivity requirements, and the impact on the business.
So when we're talking about medical devices, how many different categories are we talking about? I'm familiar with like your EKG machine, your vitals equipment, ultrasound. How big a scope is this?
This is a little bit of a gray area as far as what is really classified as a medical device, right? And depending on who you ask, you can get a ton of different answers. The way we look at what is a medical device is it needs to be an FDA approved device that actually delivers patient care in some way. So the FDA has a few different categories, 4 different categories of medical devices. But it really doesn't stop there. I think when you think about medical devices in the sense of, okay, we need to secure these and we need to be aware of the risks that it poses to patient safety should they be hacked or compromised. It's not just the medical devices that are delivering patient care. It's also things like HVAC systems, for example, or refrigeration systems for tissues and organs and these sort of things. Those being compromised or unmanaged or unmonitored could pose just as much of a risk to patients by not being able to operate when clinical operations calls for it. So, for example, a surgery room, right? If your HVAC system gets compromised and you can't control the temperature in a surgery room, well, you're not delivering surgery, and that's a problem, right? So it's not, when we talk about all the hype around connected medical devices and the risks posed, there's similar risks associated with other IoT devices within a hospital that could cause just as much risk to patient care. So, really understanding it from a holistic view and not being myopically focused on the medical device specifically, I think is an important piece to having a healthy and complete program.
So has there been documented cases of compromise with these devices? Should I, I'm a CIO, should I be really concerned within my organization that this is up in that high risk category?
Yeah, absolutely. There has absolutely been many documented cases. This is really what sparks the FDA's ramp up in communication to the HDOs around what we need to do to be prepared. So if you look like back in October, the FDA worked with the MITRE Corporation to release the, let's see if I can get this long title right. It's the Medical Device Cybersecurity Regional Incident Response Preparedness Playbook.
Wow.
And really just, yeah. So they go through a number of different steps that an HDO should prepared for the attacks that are already happening, and the trends are showing that it will happen more and more. Now, that's in general. I will say there's a ton, because that's happening, there's a ton of FUD in the space as well. Excuse me. Around, sorry about that, Perry, but there's a ton of FUD around what the problem really is, right? And I think that you'll see a lot of instances. You may have seen the news story where there were researchers that were able to implant cancer in an MRI image that really there was no cancer present in the patient, or vice versa. They could remove cancer from a patient who actually did have cancer. These sort of extremely targeted instances, can they happen? Absolutely. Is it a real risk? Sure, it can happen. Is that what we're really protecting against? I don't believe so. Unless you're the type of hospital that's really servicing super high profile patients, and the risk of something like this happening would certainly go up if you have the President of the United States being treated in your hospital, something like that, right? But for the vast majority of healthcare systems, this is not what we're trying to protect against. I think a good example to get back to your ask of is this really happening is the UK health system. And this is very public and documented, and you can kind of read what happened with WannaCry, to use a very common and popular example. But the UK health system is a very big distributed healthcare system that got really havoc wreaked on them from WannaCry. And if you read all the reports, they document a number of different medical devices that were impacted by WannaCry and as such rendered unusable, right? And so if the device is unusable, we're not talking about killing patients, right? We're not talking about a device getting hacked and then the attacker is using it to hurt a patient. I think that's where a lot of the FUD is driven, and the communication around what we're trying to protect against. The reality is the patient safety concerns more so come from the lack of the ability to use the devices if they're compromised. We don't know how they can respond. We can't trust that they can deliver safe care if they're compromised. So in the occasion that you have a ransomware attack or a botnet or some kind of denial of service type of ordeal, you just can't deliver safe patient care, and the patients don't stop coming, right? So I think that's more what we're trying to focus on and protect against, not so much these super targeted CSI style, I'm going to stop your pacemaker type of attacks. This is less the concern.
Do some of these devices have the capability to be the launch platform themselves, so they could be infected or modified and then be a delivery mechanism across your network?
Absolutely. And it's funny you asked that. I think that's the most real use case as to what we're going to be seeing more and more of in the future. The FBI even released a statement that almost half of the attacks we're going to see in 2020, and this isn't just for healthcare, but this is across all verticals, are going to be started with an IoT device. So the primary attack vector, the most easily compromised attack vector to get in and then spread from there, seems to be IoT, and the The FBI is agreeing with that and releasing communication around it. So, if you think back 3, 4, 5 years ago, and I think email still is the number one attack vector, but you're really seeing IoT creep up into that arena because of how vulnerable and known to be vulnerable, right? And the lack of opportunities to mitigate those vulnerabilities. So a lot of the manufacturers of these IoT devices just aren't releasing updates for security vulnerabilities the way that we expect for traditional endpoints, traditional IT managed endpoints, right? So they're vulnerable, so what do we do about it, right? And if the manufacturer is not going to give me an update to remove that vulnerability, do I just sit here in trouble? Do I wait to see what happens and just try to monitor them knowing it's coming? What's the answer, right? And I think this is the problem that we're really addressing, and that everybody's trying to wrap their head around what's the best way to approach this.
Wow.
Would you agree from a customer standpoint?
From a customer standpoint, I'm still sitting in that fear category, just thinking of all these devices that we do have and how really they're operated more like utility, firmware based, turn on, turn off. They just do their function and that is it. And not really looking at them as they actually have their own little microprocessor on them. They are something, they got RAM, they can be compromised.
Yep. It's interesting.
Is there a national, federal, international body somewhere that has a targeted email list that someone can subscribe to where they'll receive these vulnerability information that's specifically around these medical devices?
Sure, there's a number of different sources. So, subscribing to the National Vulnerability Database, NIST's National Vulnerability Database for all the CVEs that get released, and that's not going to be specifically for IoT, but that'll cover the best chunk of them, I think, from a single source. But there's a number of different threat sources that you can look into, depending on how serious you want to get about applying resources to a vulnerability management or a threat management practice within your organization. You said something that I think is really interesting in mentioning that these IoT devices are looked at as a utility where they're really plugged in network and they just do whatever they were intended to do. They're built for very specific purposes, right? That's a good thing. So it's a bad thing in the sense that if we don't know about it, it's harder to manage. It becomes an attack vector. If we can't have firmware updates and vulnerability patches, then it's an attack vector that can be very dangerous. But the beauty of understanding that these things were designed with a very specific purpose in mind means that if we have limited resources for vulnerability management, which the reality is most all organizations have limited resources from an FTE perspective. People needed to go patch these devices. If you can't push patches automatically via some agent like an SCCM or BigFix or LandDesk or whatever it is, you can't take a ton of manual resources to go out and manually patch all these devices. It's not a reasonable use of time for the risk mitigation you get out of it. So then what do, right? Because they're so specific in what they were built to do, we can now look at the difference between a vulnerability and exploitability, right? So even if the specific IoT device is vulnerable, and I know it's easy to be attacked should somebody target that device, take a security camera, for example, as long as I understand those interconnectivity requirements and what is that very specific task, and to perform that task, what else does it need to talk to within my environment, given that information, I can make much more intelligent policy decisions and design decisions to allow those devices to be compromised, but know that it won't cause additional compromise broader, within my broader network, right? And these type of things without the visibility or understanding of what these simple IoT devices are supposed to do and what they need to do, it's very difficult to make network segmentation design decisions. once you have a firm understanding of everything that's there and what you're trying to really protect against, or what attack vectors you want to shut off at that endpoint and not allow to go deeper, once you can really get a grasp on all of those devices and how they're coming on your network, where they need to chat, I think everybody will be in a much better position to make those proactive, preventative design decisions to stop them from being such a problem without having to manually patch all these things regularly.
So if I'm a potential device manufacturer and I want to bring my device to market, I would have to get FDA approval. And with that approval process, is there some sort of hard encoded device manufacturer's signature, et cetera, that is part of the broadcast, where when I transmit or do any sort of device interfacing, is there, kind of like with MAC addresses on NICs and stuff, there is a standard as far as how it is, manufacturer, model, etc.?
Yeah. So that's a good question. Now, there are a couple different things there. One, I think what we're talking about is like how would we find these things? How do I know what's on my network? And the network communications from these devices do broadcast what they are. So this is kind of oversimplifying it, but if you think to TCP/IP communication, and a packet header is essentially saying, hey, I'm this device on the network, will you receive my message? It's not just the TCP/IP communications, but packet headers and the handshakes of these devices and the communications they're sending to their destinations give us a lot of clues of what the device is, and in a lot of instances actually tell us exactly what the device is, the manufacturer, the make, the model, even the serial number of the unique device itself, not just what kind of device it is, but hey, on this specific device. And a lot of that is available in the network packet. The challenge is that if you think of it from a security standpoint, to liken it to the way that some security technologies work, of a 0-day attack versus a known attack. With any known attack, there's a signature for the attack, right? So now I can build into my signature engine blocking known attacks, versus next-gen antivirus or security technologies that are able to detect 0-day. So the difference there is that I'm likening this to how you detect these different devices on the network. There's two main approaches that are out there in the market. There's your statistical modeling, which would be more like protecting against 0-day, and there's deep packet inspection, which it's not an exact match or metaphor here, but that's more similar to signatures of known threats, right? And so in order to be super accurate and definitive about what the device is, using deep packet inspection to passively pick that up over the network, you need to understand what exactly you're looking for. Deep packet inspection is only as good as the database of known fingerprints behind it, right? So that's a pretty lengthy and intense process, a lot of R&D time that goes into that. So the other option is statistical modeling. So the MAC address of a device does indicate what the manufacturer is. So that can be unique to the manufacturer based on the MAC prefix. If I now can model different manufacturers talking to each other and kind of map out the network communications, I can know within a certain level of confidence that it's a specific type of device. Say that, well, I know that Alaris pump and the Alaris manager are talking because I know these are all Alaris. So I think, this is the pump, this is the gateway, and this is the server, right? And I can do that pretty well through statistical modeling. The difference in the two approaches is really around how deep do you want to get with understanding the asset. So statistical modeling will get you to a point where you understand the type of device that's on your network. If you want to go deeper into understanding the specific unique device, then deep packet inspection is really required to do that, to gain things like serial number, firmware versions even. These sort of things are found through deep packet inspection.
So I'm assuming my standard Microsoft Systems Manager, et cetera, is not set for doing this.
The problem with the Systems Manager is there's a big challenge between the clinical side of the house and the IT and IS side of the house on how we want to approach solving this problem, right? And the number one most important part of solving this problem today for most HDOs at least is let's solve knowing what the heck is on my network, right? At least just get me a baseline of what am I dealing with and what are the vulnerabilities or threats and exploitabilities. Just give me the picture of what it is so that I know where I'm starting from to build a roadmap to address it. In order to get that what is on my network, you could do active scanning, which a lot of the Microsoft technologies, you would need to actively scan your network to then pull back information about even the Windows devices that are on your network, right? The clinical side of the house typically does not want you actively scanning the network because everybody's had an experience where a scan was too heavy and it knocked a device over and then it impacted clinical operations and people's hair on fire. And so we want to avoid that, right? And this is why the passive techniques of identifying MAC addresses, modeling different devices in different clinical systems to identify what they are, or deep packet inspection to definitively define exactly what that device is and the unique identifiers. Using these passive techniques don't introduce clinical operation risk while trying to mitigate the cyber risk. So, you know, I think what it really comes down to is using traditional technologies to address even asset discovery, and then beyond that, address really monitoring and cybersecurity of these devices. We can't trade reducing cyber risk by introducing clinical risk. So this is why most everybody that you'll see in this space is doing everything they do passively. And then once we define passively what the proactive policies need to be to get to a microsegmentation place where we can really dramatically reduce the exploitability, whether there's patches or not for the vulnerabilities, we want to get to microsegmentation or zero trust around your most critical devices especially, but really the more devices you can have down to a microsegmentation strategy. I mean, that's the more you can do that, the better. That's great. But you know, to answer your question, I think that using traditional active scanning technologies, for the most part, is going to be opposed by the clinical side of the house. Are you experiencing that in your hospital? Have you had that debate internally?
Well, what's really coming to mind right now is I'm thinking both on our client and server end in our environment, we have antivirus software, anti-malware software. But with these devices, how is that being, how can I scan for it? Because I'm sure my antivirus vendor is not looking out for this plethora of vulnerabilities around devices, the IoT devices. It's just like the Windows operating system or what have you. How is there a market? Are there products, appliances, something that do this this passive monitoring and look for signatures that are specific to IoT devices?
Oh yeah, absolutely. So the company that I work for, Medigate, is leading this specifically in healthcare. So there's a number of different IoT security providers that are addressing many verticals. There's a few that are addressing specifically healthcare. There's a few that are addressing specifically industrial control systems and SCADA protocols. And so I think the answer is yes, there's many and more coming into the market every day. I think when you look at who should I evaluate or who should I bring in to help solve this problem, what's happening around IoT, so back to kind of how we started this conversation, what is IoT, right? There's a maturation going on in the industry in general. In the industry I've called the IT or information security industry. There's a maturation of understanding of how to address this problem. So as we all get a little bit more understanding of what's really important from IoT, what's most critical, certain industries have certain devices that are most critical to them. So manufacturing, for example, the industrial control systems are for sure going to be their most critical devices that they need to ensure are well protected, well defined, well inventoried, understand the vulnerabilities and exploitability. In order to do that, we know deep packet inspection is the best possible approach to getting super granular about what I have in front of me and the vulnerabilities and the problems that I need to solve. So a lot of manufacturing companies are choosing industrial control system focused companies like CyberX or Forescout even bought a company called Security Matters, right? That was doing this, very focused on manufacturing. Then you've got general IoT partners that look at more standardized network protocols and gather the most information about all the devices connected to your network as far as the most breadth of devices, right? To just get you an inventory of, hey, this is what's out here. Here's my potential risks, but maybe not get as deep into the specific vulnerabilities or how to write a policy or build that policy to control the device. In healthcare, there's a much greater challenge than any other industry because the manufacturers use very proprietary protocols with the devices. So in healthcare, the breadth of devices specifically for patient care is massive. And the protocols, there's more protocols in a healthcare network than in any other vertical. And they're rarely shared. So, you've got DICOM, which is shared across all imaging devices. You've got HL7, but that's really, just taking all different types of protocols and converting them to be able to speak back to the EMR. Those give you a lot of information about at a certain level, but if you really want to get deep around all the devices, you have to understand these proprietary protocols. And that's the big challenge in healthcare and why this is still an evolving space. And there's a number of different technologies that are addressing it and getting better every day. But I think at this point, there's a number of players that can do a very good job of at least getting customers or HDOs a baseline of how to build that program, get that visibility to at least understand where you are and how to build a program around it.
Do you know if IEEE has a standards body working on a draft?
I don't know if IEEE does. There is a Health and Human Services release from December that is really focused on the top 5 areas of importance for healthcare specifically from a cybersecurity perspective. The part of the challenge here as well is that healthcare is notoriously behind from a cybersecurity investment perspective compared to like finance or a lot of the other industries, right? And so that's no one individual's challenge. Healthcare is a very low margin business, which I think that people have a misconception around the money that hospitals make. There's very few hospitals that really make big profits, right? And most of us are operating on 2, 3, 4% profit margins, similar to the grocery, industry. And so it's not the HDOs that are making all the money. And so it's not from a lack of understanding that the risks are out there. It's really just a lack of funding and a lack of hospitals just don't make a lot of money. And that's the reality. But there are a number of different sources that are coming out to say, look, let's prioritize. We're not going to solve this underinvestment problem overnight. So what are the top most important issues that we need to solve? So the Health and Human Services guide will give you 5 of the top areas that healthcare organizations, HDOs, need to invest in to at least bring their cybersecurity posture to a kind of baseline industry minimum. Those are email security, IoT and connected medical device security is one of those top 5 as well. And that's publicly available to get that report. And we can probably put a link for the audience here to be able to gather that. There's also ECRI, I think. ECRI is a good source of helping to sort of see what's most important to address. They're a patient safety organization, and they do research in all different areas from different types of patient care techniques to even things like healthcare technology and what's the best technology to use. And they release a top threats to healthcare technology every year. And unfortunately, cybersecurity attacks on medical devices, network devices, has been their top threat to healthcare technology 2 years running. So when you talk about how do I go and garner support from the board to spend the little money that we do have to address these problems, I think it's really important to look at it from a perspective of, in healthcare, IoT security isn't just about network security. Because of this plethora of different and unique medical devices on the network, it really comes down to patient safety, is understanding what's there and how that attack vector could be exploited and interrupt patient care. None of us want to get to a point where we have to deliver or redirect patients to a neighboring hospital because our network's been compromised and our devices are locked down. So it's really a patient safety concern, and it's something that is certainly a top priority to be addressed. And there's a lot of industry, third-party, nonprofit organizations that have a lot of advocacy around that to help bring the boards and gather the appropriate funding.
I was thinking, let's say I'm a small practice, outpatient practice, and my patients, I like to have them use a Fitbit, and they come in and I just download information from their Fitbit to my laptop. When it comes to the deep packet analysis and checking what gets attached to what that we've been talking about, does that also cover the consumer items?
So it can, a little differently though. The Fitbit, that's a good example. So I think what it comes down to, it's going to be more difficult to monitor the Fitbit from a cybersecurity perspective of if it's being attacked or what's going on, because you don't have active monitoring over the Wi-Fi that Fitbit is using or the Bluetooth connection to their personal phone. So it's going to be harder to monitor the behavior of the device, right, for a cybersecurity attack. But I think what we can do is make sure that the Fitbits that we're delivering, if we as the clinic or the health delivery organization is issuing the Fitbit, modifying that Fitbit so that it can't openly communicate, right? Of just creating a policy for that only to be used for the health monitoring purposes or data gathering purposes that it's intended for, and only able to communicate to our servers as the health delivery professionals, and not open communication to connect to whatever the patient would like to connect to, which will introduce more and more cyber risk or attack vectors that can be compromised. So I think it's having preemptive security thought around the security or around the technologies that we want to use for wearables and data gathering and different studies and these sort of things. Just issuing them with that security in mind ahead of time.
Well, we're talking about, I'm thinking back now again on the security of this transmission, where traditionally on the network sets for network transmission, we have various encryption protocols, AES, etc. Do these devices employ the same, or do they have a completely different protocol that exists on the network? I'm thinking of the tunnel for that communication. How secure is it?
That's a good question. So that very much depends on the healthcare organization itself and what they've deployed. Not all devices are created equal. So some manufacturers have better encryption than others. One thing that we're seeing a lot of now is capsule gateways, right? These medical device integrators that connect devices to that maybe didn't speak IP previously, and then we can now make them network enabled. And these capsule devices have incredibly strong encryption, and from what we find, that's very sufficient. There is a number of devices out there that don't use encryption for the data in transit, or even the data at rest, for that matter. The answer is it's a mixed bag, right?
Okay.
And that's part of the challenge, is figuring that out.
Do you know, is there like a certification standards body or someone where you can get the Good Housekeeping seal of approval for, yes, this is past our QA, it's certified for this, and this, around the security end of things?
Yeah, so there's actually MDS squared forms that are being released with new devices more and more. So I think what you're going to find in the trend in the industry, new medical devices that you're going to procure, I think it's a good practice to start looking at the security of the device before buying a device. This should be incorporated into your onboarding or even your procurement choices around what medical devices are you going to bring onto your network. So doing some analysis around that as good. And there is actually a standardized form called an MDS squared form, which is the manufacturer's disclosures around these different security risks and the configurations of the devices. So you can get a lot of information around new devices. I think the biggest challenge or the biggest risk, though, is the legacy devices that you have that were purchased before anybody was really even thinking in this way, or very few people were thinking in this way. And when you go to the manufacturers for those, unfortunately, a lot of times you go, oh, well, just buy the new device, right? The new device has security in mind. Well, that's great if that manufacturer is making big profits and that money grows on trees. The reality is for HDOs, it does not. And when you buy a device with an intended 10, 15-year life cycle, and it's only 4 years old, 5 years old, you're not going to be able to replace $1 million device just because the new version of that has certain security built in, right? And so I think going forward, as fleets start to turn over and you're refreshing into newer generation medical devices, more and more of them are being built with antivirus built in. More of them are being built with really strong security standards in mind. The unfortunate reality is it's going to be probably a decade or more before HDOs really rid themselves of all of the devices that are inherently completely insecure or unsecure. And how do we control that exploitability of these known to be vulnerable devices in the meantime until we can really refresh our fleets?
So you do see someday in the not completely distant future where it's commonplace now when I look at anything, one of the questions is always, is it HIPAA compliant? There will be something that would be in my lexicon that I would use when it comes to medical devices.
Yeah, absolutely. I mean, HIPAA compliance is, a lot of, from a medical device security perspective, a lot of that has to do with, does it store PHI? Does it transmit PHI?
Yeah, that was my example. That's what I asked today. But when it comes to medical devices, will there be the whatever acronym certification or compliance that gives me that trust that this vendor meets the requirements for security with their device?
I certainly hope so. I can't answer that question. It's a slow-moving process. Anytime I could say that they did present a bill in Congress. It's not law. I don't think it ever passed yet, but in May of 2017 even, so it goes back that far, that Congress is looking at these sort of things. So and that was the Medical Device Cybersecurity Act of 2017 that was presented then. And not to say that any of that's law or regulation, we're not there yet, and it's very slow moving to actually get something like that passed. We're talking big industry with the medical device manufacturers especially. So will that happen? Hard to say. Should it happen? Absolutely. So part of this is everybody kind of.
Since you mentioned the federal government, is there any lead agency that is keeping this kind of on their agenda, HHS or the FDA?
I think the FDA is really leading it, but HHS is, maybe just as heavily involved, and even Homeland Security ICS CERT is very involved in just releasing communication around vulnerabilities and helping people understand what the risks are and what to address. So, this has gotten to be a really big issue. Part of it driven by hype and the FUD, and the government needing to respond to show that they're actively trying to help protect the population. But a lot of it driven by the reality of how vulnerable these devices are and the lack of security and even understanding of how much risk is posed to the different HDOs. I don't think that there's anyone leading the charges. I think it's kind of all hands on deck to be able to address this and find the right model, find the right regulation and programs to get to a point where our heads aren't spinning trying to figure out how to address the problem.
So what I'm hearing is what I should be looking at now is even another element to my utility belt. If I have any of these devices within my organization and I'm using them, I need to now focus in on mitigating a potential risk here too.
Without question. Yeah, it's funny because if you look at let's say a hospital specifically, let's say take a large hospital. If you look at the mix of endpoint devices that would represent some sort of attack vector, whether that be the laptops, bring what your own, BYOD devices, medical devices, whatever, right? If you look at the mix of devices, the vast majority of our security budgets are spent to protect the servers and our laptops and the traditional IT devices. Yet, a lot of hospitals have at least that number, if not many, many more medical devices than they do laptops, desktop servers, right, network devices. So I think it's really important to start shifting the way we think about how are we deploying our security budget, what's the most critical to the mission, and the mission is delivering patient care. And so if these devices that are directly involved with delivering patient care are completely ignored from a security strategy and budgeting perspective, I think that's a miss, right? And I think most HDOs are realizing that and are starting to shift dollars and even come up with dollars that weren't budgeted and pull from other budgets within the hospital, whether that be clinical engineering. I've even seen just revenue operations jump into the mix around a lot of these security technologies. Because of the way they're built, they'll also be able to tell you how often devices are being used. So things like outside use cases, I'll call it, that these technologies that are in this market are able to deliver can actually help show operational efficiencies as well, while really the main focus or the main mission is to deliver security of the devices. But knowing how tight budgets can be with hospitals, I think everybody in this space is trying to deliver efficiencies as well, operational efficiencies and utilization analytics to help really increase revenue, whether it be through imaging cases, scanning cases of whether MRI scans, whatever it is, these higher dollar, higher margin revenue opportunities for hospitals, and just understanding how to best leverage their existing assets and investments, right? So everybody's trying to also do that to help minimize the impact of the cost associated with this new type of technology, a new type of security program that HDOs really need to engage in. So I think everybody's trying to kind of do their part to make it as minimal impact on the budget as possible, if not even, a good, strong ROI in the short term. So
well, I think it'd be great if I were to go into an exam room and I don't see any wires anywhere, and the equipment that is monitoring is very minimally invasive. And as a patient, when you see a bunch of wires everywhere, you can get some anxiety.
yeah.
So I'm really a proponent for the IoT way of doing things, and I think you provided enough information to ease a little bit of that FUD that I had coming in. So thank you, Drew.
Yeah, well, I appreciate you.
What do you see? What do you see for the future? If you could just look at your crystal ball right now for the next 24 months in this space, what do you see is going to happen?
Well, I definitely just see the number of connected devices growing really rapidly, right? So if we think of the patient room of the future, the number of connected devices and the interoperability of those devices, how much they actually leverage each other and automation of sharing information between the devices is only going to go up. So the complexity of the interconnectivity requirements is increasing and the number of devices is increasing. So the need for organizations like Medigate and Order and Assembly and Armis and all the different players in the space that are trying to address this will also rise. So I think that the organization's ability to really understand these clinical protocols specifically, to get deep into defining the interconnectivity requirements and therefore build policies to allow only proper communication is going to be key. So I think everybody's starting to do that pretty well, some better than others, right? But having a tool to automatically identify that and automatically build policy so we're not reliant on the human element and human error and just the time limitations and resource limitations from a human FTE perspective will be absolutely critical. But if we can do that, then I think that we're in a really good position to protect against what's coming and the potentially increased attack surface that we do have technology now to reduce that back down to even smaller than it was 3, 4, or 5 years ago when people weren't as focused on this problem.
Well, thank you, Drew. This was extremely informative. On behalf of the Arizona chapter of the Health Information and Management Society, we give you a big hurrah thank you for educating us for an hour on a topic that I didn't know much about until now. And I'm going to really dig in to what we have in our deployments at the moment and see if we can make them a little safer for the patient.
Fantastic. Well, good. Thank you, Perry. It's good to hear. And I hope this was helpful.
Definitely. Thank you, Drew.